So this is the project from last week, and this is the solution file. I don't think we have a lot of files in there, but let's take a look. We'll just say open single link list and see what it shows. Interestingly, it points to the header file and the main file. Okay, so it's all there. So let's take a look. Yeah, and I remember that what was happening is that before the class ended, what we introduced was this little element, syntax element, which we call member initializer list. So we say if our class contains this type of data and this type of data, then we would like to use member initializer list in our constructors so that we can efficiently populate those data pieces with initial values. And therefore, this is our decision. As opposed to use assignment statements inside the copy constructor, our choice will be to use member initializer lists in our constructors. This is the member initializer list, by the way, is the structure or syntactical list that can only be used with constructors, nowhere else. This is specifically to provide a way to initialize data members of our classes. Okay, so far my node is kind of small. How about I keep it clean? So what I would like to do is to create another source file. Just add another source file, and I will name this source file node.cpp. So implementation file, we'll say node.cpp. Add that, and it will contain, clearly it needs to include node.h. This is already existing header file in my directory. Okay, so do this, and then clearly, if I don't need this for now, if I move this to a previous tab, what I will do is I will take this thing from here and Control C, copy it to my implementation file. You can always do Control A, Control KF to automatically format your code. But the only difference, if I try to code my function, this particular constructor, I can actually say this is a constructor, right? I need to specify that this constructor belongs to this class. So all I need to do is to obviously prefix this with the class scope, because this constructor comes from the class node, which has the scope right here, and obviously inside the header file. Now, instead of providing the implementation, I can keep my interface kind of pretty clean, so that instead of defining functions here, I will be only declaring them here. To make sure that nothing is broken and everything more or less works correctly, and our main function still not broken, that we can still create nodes, what I would like to do is to say build. I already told you, anytime you modify the project structure, such as you add files, rename files, or any of that nature, it's very helpful to say clean, because get rid of any intermediate files from previous builds, clean that, and just then say wait for it to finish, and then say build a rebuild solution, so that you have a clean build after cleaning it. And oh, I recall that I've turned on all warnings here, so let's maybe I will just ignore some of the warnings that come out from the standard library here. Not to worry right now. They're just warnings. Okay, so I have two nodes that I'm constructing in my main function, and obviously they go and they use this class. So this class wants to be a node which can make a list relationships with other nodes, but so far it only has a constructor which does something useful. It takes the value, but so it stores the value in a data piece right here, right? So we already populate the integer value in our payload. But another important thing that this constructor already does, that it takes pointer to the next node and immediately initializes it with null, right? So which is like 0 pointer, to make sure that it formulates basically when we just create, say I wanted to create two nodes like I do right here. I create two nodes. So initially when I do this, what happens that both of them are constructed with null pointers, right? Because the constructor intentionally sets pointer to the next node to null. And so I have two, sort of like two lists with one element in them, and both obviously not linked to anything else. So when I create them like this, they're already created and not doing anything list-like, but they already have this pointer to null, which we're about to modify. So going out to this example here, let's see if we can maintain the functionality here. So Control-C, copy from this example, right? And then we go to our header file and we paste this in. So let's take a look. Paste this in. Let's see if we can make it all visible. This is unnecessary toolbar for us. Save that. I will get rid of this constructor declaration. I have my own constructor right here. So there will be an insert function which says if someone calls this function, then it should be inserting something in front. So there's also remove next, which basically says that if I have a node and someone calls this, regardless to whether there is another element or not, it will be removed from the list. It will essentially, this node will be taken out of the list, I believe, or no, it will be used as a root which says remove next. So we'll talk about it during the implementation stage. We also would like to know the size of our list. Essentially, we'd like to say how many elements are present. What is the size of this list? And we also would like to be able to calculate distances between two nodes. And the reason to have this fancy function named distance is that because if you calculate the distance between the root node and the last null pointer, it should actually provide implementation of size, because this is the expectation, I think, of this particular design. So let's take a look. All right, so this is the plan to implement insert, remove, size, and distance between nodes. So let's explore, right? So moving to the next one. So the constructor, we'll already have it. We're happy with that. So again, using initializer list as our base syntax to populate data of our objects initially. And so here comes a proposed version of the insert.